Hello and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video 10 in the series Word Problems. So I've heard many times that we don't really learn mathematics that we can use in real life in a math class. And I think that is a very valid criticism. However, when we start to do problems that can be used in real life, or we start to address the connection between math and real life, that's usually where students have the least amount of fun. I say, okay, well, it's time to start word problems, and everyone groans. This is the worst part about math class. Why on earth are we doing this? Well, the criticism is unleveled then, because precisely word problems are how you apply this to real life. Now, whether or not those are good word problems or not, that's another discussion, right? Word problems can be very boring, and I get that. But the main idea is that if you want to know how you can take this from this boring status of symbols that you push around on paper and make this work for you, you need to attend to how you can do that to these pre-canned type of examples. Right? We're going to look at other examples that maybe don't apply to you, but it's up to you to try to see the connection between the words, the setup, the situations, and the mathematical relationships that those situations imply. Because if you can do that and you can do math, then you can solve the math problems and figure out how that relates to your real problems. A word problem is just a verbal description of some situation that has a math problem at its core. It's a question with some kind of setup. There'll be details that we need to sort of decode and understand what's going on. So there's a linguistical component to this. But those relationships between those quantities are going to be mathematical in nature. And it's our job to try to see the math problem at the core of the word problem. So in other words, to do a word problem, we have to strip away those details, the ones that don't really affect the mathematics, and see the mathematics that's going on at the center of the problem. But I just want to note that, in fact, that makes it seem like the details are unnecessary. And it's the stripping away of it that lets us solve the problem. But that's not exactly true. The relationship between the details and the math, the way that the flavor text of the problem relates to the pertinent mathematical details of the problem, it is that relationship. It is seeing that relationship that is exactly the skill that lets you apply math to your real life. So how do those mathematical facts relate to those linguistical facts? If you can see that connection, then this becomes applicable for you. And until you can see that connection, math will be a dead, boring subject. I know most people do not have as their principal concern developing math into a tool set that they can use in their real life. And that's a cry and shame, because that really is what it should be. Most people, I understand, are in their math class so they can get through it, get their little certification done, and never have to do math again. Like that ever actually happens. But as far as solving these problems are concerned, we are going to be stripping away the details here. We are going to be focusing on getting from details to mathematical facts and the relationships that are implied by the problem. That is our first goal. Now, once we can see what those main players in the problem are, we're going to assign symbols to represent those quantities. And then we want to write down equations that express those facts that we were given about those quantities and the relationships between the quantities. Once we can write those down as equations, then we can use algebra to solve those equations for the desired unknown quantities, and so that we just substitute in those given quantities, the known information, and evaluate our equations to get the desired unknown quantities that we are looking for in the problem. So here I have below summarized that step-by-step process for analyzing word problems. These are critical notes. You need to copy these and show me them on paper so that I can validate you've watched this video. And to just go through it again, these are your general guidelines for word problems. You identify the known given information and the unknown, the desired quantities, and you give symbols to those quantities to represent them. Then we want to identify the facts and relationships between those quantities. We want to write down those facts and relationships as equations. We solve those equations perhaps substituting one into another for the desired unknowns. And then finally, we plug in the numbers and evaluate. I want to suggest that you don't jump into plugging the numbers in as soon as possible. That you don't just immediately say, oh, well, I know that, x is 4. Ooh, and I plug it in. And then we lose that x forever in our setup. I want you to, if you can show this discipline, to try to leave them as variables until the end. Because it is in this way that you will, number one, get better at algebra, and number two, be able to see the relationships clearly between those things. Once you plug in numbers, those relationships somewhat disappear, and you're left with just this stripped down version. It feels simpler, but it actually isn't any simpler. It is just as easy to use the algebra and only plug in your numbers as a last and final step. I strongly suggest that you do this. You will get the right answer either way, but in one way, you won't really see the relationships that you're losing when you plug in those numbers just immediately. So let me give you an example. Lunch costs $27.50. We left a 25% tip. What was the original cost of lunch? Okay, so let's think about it, and let's consider the quantities at play. Let's consider the relationship between those quantities, and then let's solve for the unknown variable. Number one, we want to identify the known and unknown values. These are the total cost, the percentage of the original cost that was our tip, and the original cost itself. Two of those are known. We know what the total cost was, and we know what the tip percentage was. We don't know the unknown cost. So let's give them names. Let's say total cost is big T. Let's say tip percentage is little t. And let's say that the unknown original cost was X, because that's a pretty classic name to give to the unknown. Now we want to identify the relationship between these three quantities. Total cost is going to be the original cost plus whatever tip that we left. And tip is usually a percentage, of the original cost. Now, when you see the word of, that is a key math word. We usually say of when we're referring to multiplication. Of means times. And so we will see that what we're going to do with our percentage to get the tip from the original cost is to multiply them together. But let's just write down what are the relationships as equations. So the first relationship is going to be that the total cost T is equal to the original cost plus some tip. And now tip is the percentage of the original cost that we left. So 25% times the original cost, that'll give us our total tip. And then this just says original cost plus total tip. Now, we've got an equation. We just need to solve it for our unknown. So let's solve this equation for the unknown quantity x. I have t equals x plus tx, so I have two terms involving an x. I could factor out the x and write t as x times 1 plus t. Notice you need the 1 here in order to hold place for this x. If you distribute this back in, you want to get the above line, and that requires a 1 to go here. To get rid of that term that's multiplying by the x, we simply divide by it on both sides. It cancels on this side, and we just have x. Now that gives us big T divided by 1 plus little t is equal to x. Notice that I know these two. They are given information. I definitely know what 1 is as a number. And then x, that's the unknown, that's alone on this side. We've solved for the unknown quantity. Then we plug in that known info and evaluate. That would be 2750 divided by 1 plus 25%. That's just the following, 27.5 divided by 1.25. This would be the step where I would bust out a calculator and say 27.5 divided by 1.25 equals 22. So we get $22. Now, what I was saying before about holding off plugging in numbers to the end, yeah, you could have plugged in 25% right here. It would have been fine. It would have been fine. This would say x plus 0.25x, and we would just continue in this way. But then you would miss out on this equation here, which actually works for any value of t. The whole point of algebra is that you don't just get one answer, you get every answer to every possible total, tip, and original cost. And you'll miss out on that kind of generality if you're so gung-ho about plugging in the numbers right off the bat. Okay, so now let's work on a praxis exercise. I want to see these in addition to your critical notes to validate that you watched the video. This one says, a rectangle is twice as long as it is wide. If it's 4 inches wide, what is its perimeter? So pause the video and give this a shot. Think about it. Okay, let's take a moment now and see how you did. So I should have probably mentioned a really good step 0 for these word problems is, if it's applicable, if you can, draw a picture. Try to use all of your faculties towards deriving the meaningful relationships at play. In this case, I have a rectangle. Rectangles have lengths and widths. They kind of look like a box with perhaps unequal sides, although squares are also rectangles. This rectangle I've drawn so that it is roughly twice the length that is its width. That's really just artistic. The better you can draw your picture, though, the more you can use it to furnish your intuition. So now let's write down some of the quantities and give them names. We have a length, let's call it L. We have a width, let's call it W. And we know that length is twice width. That's a relationship. We were also asked to find its perimeter, which is the total distance around the shape. So maybe that deserves its own name, P. And we need to know a few things about rectangles. That rectangles have 2 equal lengths and 2 equal widths that make up the distance around the rectangle. And then step 2, let's combine those facts into equations. So we know that L is equal to 2W. Yes, that means L is 8. Hold on. Just let the algebra do its work. Let it cook. Now, P is 2 lengths and 2 widths. So the perimeter of a rectangle is 2L plus 2W. Let's express that, right? Let's put these 2 equations together. If I take this equation for L, remember our axiom of substitution, it says if I know L is equal to 2W, then everywhere I see an L, I can replace it with 2W. So I do. And now this gives us an expression for the perimeter that only has a single W in it. 2 times 2W is 4W, and 4W plus 2W is 6W. Now, this is a much simpler expression for the perimeter, you would agree. And you would miss it if you had just plugged in the 4 immediately. Just hold on. See if you can see the relationships that are going on here. Now, in step 4, you usually solve for the unknown variable, but I asked for perimeter, and hey, this equation is already solved for P, so that step is unnecessary. We plug in 4, we get 24. This 4 had the unit of inches. We'll talk more about units in subsequent problems, but for now, if our distances are given in inches, our perimeter should also be measured in inches. So the answer is going to be 24 inches, and that completes the problem. Okay, thank you for your patience. Have a great day, and good luck with your studies.